Good afternoon. My name is Todd Christensen. I'm the Director of Marketing at QSI Corporation. I'd like to thank you for joining us today for our Intermediate IX webinar. Today we will build on what we learned in our first webinar and create a multi-controller application, learn to use an OPC server, an alarm distribution server, and audit trails. If you missed the first webinar, it is available on the website at ix.qsicorp.com. A quick orientation to the GoToWebinar control panel. If you do not see a window on your computer that looks something like this on the slide, press the red arrow button to expand the control panel. This presentation is approximately 50 minutes long, followed by a 10-minute question and answer session. If you have questions during the presentation, please use this window to type your questions, and we'll moderate that at the end of the presentation. I'd like to introduce Axel Gustafsson, an application engineer from Beijer Electronics. He will be in charge of the remainder of our presentation. Axel?
Thank you, Todd. So my name is Axel Gustafsson. I'm from Beijer Electronics in Sweden, and we are the company behind the IX software. So the agenda for today's webinar is that we will start with, as Todd said, a multi-controller application, then move on to external OPC server, alarm distribution server, audit trail, and in the end we have some time for questions. So to start with the multi-controller applications, IX makes it very easy to add multiple controllers to your application. And it's very easy to create data exchange flow between these controllers. And you can even change the active controller in runtime. So you can have one IX application that's configured for multiple PLCs and then switch in runtime which PLCs the application is communicating to. This lowers the upkeep on applications since you only need to have one application. So if you need to make changes, you can do it in one place instead of maybe 2 or 3 or 4. So multi-control applications, I will here go through a couple of scenarios on how we can do this. And to start off, we can have one PLC communicating to the HMI. And it can be a Mitsubishi Q CPU. And then what you can do is, if you have configured the application to work this way, you can then in runtime hit a button and change the active controller to a Siemens S7-1200 in this case. Or hit the key again and you can move over to a Control Logics from Rockwell. You can also do is you can have multiple PLCs connected at the same time and have a data exchange moving between these PLCs. So having the HMI as a gateway in the middle, moving data from one PLC to another. And this can be configured in several ways, either with a specific time interval or on data exchange or on value change, meaning that you can, if the value changes in one PLC, you can move over that value to the other 2 PLCs in this example. So how this actually works inside the HMI is that if we have two different UI elements on the screen. We have a circular meter and a slider, and both of them are connected to the same tag. So how this works internally is that these 2 tags are communicating with our internal communication server. You can see here on the HMI we have tag 1. And then that is then mapped to the different physical addresses in the PLCs. So in PLC 1 you have DB1, you have D1. In PLC 2 you have DB1, DBW1, and in PLC 3 we have data item 1. So the communication on the screen, the graphical user elements are actually communicating to the COM server, which is then distributing this communication to the Siemens PLC or the Mitsubishi PLC. So it's very easy for us in runtime to just deactivate one of the PLCs, and then the communication will only be carried out to the other two. So now I would like to show how to configure this in IX. So I will move over to IX. Here I have a simple application which I basically done exactly the same thing as I did in the basic webinar, adding a background screen with a couple of tabs. So to configure the actual controllers, we go into the tags function, and by default when you create your application you only have one controller, you have controller 1, and everything is blank now. So what I would like to do now is to add a second controller to this application. So I go to the controller tab and I click add, and I add a second controller. In this case I'm using the demo drivers because it's easier for me to demonstrate that, but if you had, this works exactly the same way if you had physical PLCs that you're communicating to. If you're using multiple PLCs, it's very good to use a name for it that's more intuitive than controller 1. So in this case I'm using demo drivers, so I will just call them demo 1 and demo 2, and I will give them a short ID. This is used to easily have a good overview on the data exchange. You can select if they should be active by default or not. So let's go back to tags. You can now see we have 2 controllers instead of 1. So if I want to add a tag now, I have a tag called tag1, and then I connect them to the actual physical address in the PLC. So I will connect them to D0 in both PLCs. So now I have one tag that's communicating with 2 PLCs, and without configuring any data exchange, this tag will write to both of these tags or both of these PLCs, but it will only read from one of them. So in order to move the data in between, I need to configure data exchange, and that is done here, the data exchange column. So I just click here and select how I would like this data exchange to be configured. So I want the data to move from demo 1 to demo 2, and at the same time I want it to be moved from demo 2 to demo 1. So if I have a value that changes in one of the PLCs, I would like this to automatically be updated in the other PLCs. You can see now we have the shorter ID name of the controllers showing here, so you can much easily see this. The last thing I configure is the when. When do I want this data exchange to be carried out? The default is on value change, and this is good because it makes the best use of the bandwidth that you have available. But you can change this to a time or on a tag, so you can have a tag trigger the data exchange. We'll leave it at value change because that's the most useful option. So now I have a tag, but now I want to be able to show you that this is actually happening. So I will add 2 other tags. One of them will be connected to D0 in one of the controllers, and the other one D0 in the other controller. So now with these tags I can look at only one of the controllers. I'm only reading and writing to one of the controllers, and I will not have any data exchange in this one. So if we go back to the screen here, and we will add some devices for this. So the first one here will be tag 1, which is communicating to both of the PLCs. And we will have 2 others configured for the tag 2 and tag 3, which is only communicating to the PLCs separately. So let's also add a button so I can show you that you can disable the PLC communication in runtime. So we add a button and we go to Actions. We select Action. This is done in Controllers and then Change Active Controllers. Let's give it a better name. So let's run this. So what we will see now is that when I change the value in tag 1, it will automatically change in the other two. And if I change one of the other two, it will change in between. So if we start off by changing the value in this tag to 10, we're now writing down to both of the physical controllers. And since we have data exchange configured, if I change the value in one of these, it will automatically be moved over to the other PLC and the other way around. And so this is how easy it is to configure data exchange and a multi-controller application. If I want to change the active controller, I hit the button I just created, and I will be presented with a pop-up window where I can, with checkboxes, select what controllers I would like to be active. So if I disable one of them and only have demo 1 active, hit OK. It says that I need to restart application. This is needed. So if we close it and start it again, we can see now when we change the value, it's only updating one of the controllers. And the same here. So you can see how useful this might be if you have a package, if you are in a machine building business and you have many different PLCs and different machines, but you only want to have one HMI application. You can just put the HMI in, hit the button, change the active controller, reboot, and you're up and running. So that's multi-controllers applications. Moving on to external OPC server. IX connects to an OPC server as an OPC client. And when this is done, the OPC server will handle all the communication. So you will have one central point for the communication to all your PLCs, and then that is then distributed to different panels or PC applications that are connected to this OPC server. You can have multiple clients connected to the same server, and you can distribute it using Ethernet to multiple panels. And any OPC server works. We, Beijer Electronics, have our own OPC server, but this works with any OPC server that follows the OPC Foundation standards. So the scenario might look something like this. So you have 3 different PLCs, all communicating to a central PC, running an OPC server. And then what you can do is on the same computer you can have an IX runtime, a PC application running, and handle and then take part in that communication. And this is what I will show today. But you can also do, this means a local community, but you can also do, you can connect a panel to the OPC server using Ethernet. And this way, using DCOM, you can distribute the communication over all your network. And the really good thing about this is that you can have multiple panels connected to the OPC server, which means that if, for example, if you were to have a 232, a serial connection, it's only point-to-point, you can then distribute that point-to-point communication to a lot of different PLCs. So you have the possibility to both do remote and local communication. And you can do both of them at the same time. So let's move over to IX again, and I will demonstrate this. Add another screen. So to do this, I add the OPC server as any other controller. So in the same way that I added demo 2, I can click add here, but instead of selecting a controller, I can select an OPC server. And here I can select either localhost or remote server. Localhost means that the OPC server is running on the same computer as IX is. And remote server is that if we were to use a panel, for example, that's distributed somewhere on the network, we would click remote server and select the IP address of the PC that's running the OPC server. And in this list here you will get a list of the different OPC server. In my case I have 3 installed. I have one from Beijer Electronics and 2 from Allen Bradley. I will select the one from Beijer Electronics because that's the one that's running right now. So let's hit OK. So you can see it's added as any other controller. So I will change the name, give it an ID. So just to show you that we have an OPC server running here, this is the Beijer Electronics OPC server. I have a couple of devices configured. This is then communicating via Modbus to another panel. We can actually see that here. So here you can see this is the Modbus slave, and the OPC server is acting as the Modbus master. And we have a couple of devices here, different values. So if I go back to IX now and go back to tags, this is where so what I would like to do is I want to add the tags that already exist in the OPC server. I would like to add them to my IX developer project. So I just click add and I select I want to add them from an OPC server. And it shows me a box with all the different tags that are configured in the OPC server. So I have the devices here and also have some diagnostic information for the OPC server. I would like to add everything, so I have to click the topmost checkbox in the tree and click add. So we're now importing all the tags that exist in the OPC server. It gives them a name, the same name that it has in the OPC server. And we are now connected to it here. It even imports the correct data type. So then this is treated as any other tag in IX. So I can just add analog numeric with this tag. Let's add 2 of them. And you could configure data exchange on an external OPC server as well. It's treated as any other controller, except that you have this high-level bond between the IX and OPC server. So if you change a tag in the OPC server, it's automatically updated in IX. So I'm just gonna configure a block jump so we can jump to that screen. So let's run it. So we're compiling. So to show this, I now put up the Modbus slave in the background here. So the communication now is going from the IX application via OPC Client server communication to the OPC server, which is then handling the communication to the PLC. So there is no protocol between the IX application and the OPC server. So I can change the value in the OPC server and it's updated in the Modbus slave. This type of communication is very useful. So that's external OPC server. Move on to alarm distribution server. So the alarm distribution server in IX allows you to distribute alarms to different media. So when an alarm occurs, you can have it, the alarm text, the condition, everything be distributed via SMS, via email, or via printer. This distribution can be scheduled so that on different times of day, on different days, different receivers will receive the alarm information. So if you're on your factory floor, you're running a 2-shift setup, you can have in the morning, you can have the alarms be sent to the people who are working the day shift, and in the night you can have the alarms be sent to the guys who are working the night shift. And you can also have one server and many clients. This means that if you have a PC or an HMI as a central point which is connected to a printer and have internet access, that can then act as the server. So this can be the only PC or HMI that has connection to a printer, for example. Then all the other HMIs in the network can send its alarm information to this alarm distribution server, which is then handling sending out the emails and SMS and printing. This allows you to make a more secure network and a more cost-effective network. So this is how it might look. You might have alarm server up here, which is sending out SMS, email, printer. Then you have the clients down here who are generating the alarms, but all the alarm information is sent to this central server, which is then sending out the SMS, email, and printing out the alarm. So let's demonstrate this. So to do this, I need to add an alarm distribution server to my application. I do this by right-clicking and add alarm distributor. So the way we configure this is that we first start by creating the different routes that will receive this information. So in this case scenario, I will create a 2-shift setup. So route 1, and create route 1, and I will rename this to day shift. Then I select what people should receive these alarms during the day shift. IX has its own address book, So you can add a couple of names. I will create 2 names and call it Axel, and an email address. And a phone number. This is not my real phone number. Let's just make it. So this is then used by the application to send out SMS and emails. And one thing to note is that the SMS are not, it's not that you don't need to connect that GSM modem to send an SMS. You actually configure a web SMS service. You can use any third-party SMS service to do this. And that then is sending out SMS. So there is no need to connect that GSM modem to the panel. So that's the address book. So let's add a couple of receivers. So during the day I would like me to receive an email and an SMS, and I would like it to print. So we can see our email to Axel, SMS to Axel, and printing. And during the night I would like Patrick to receive email and SMS, and we would also like to print it, so we have a hard copy of the alarms. So the next thing we can do is that we can filter what alarms should be sent. We might not want to send out every alarm. We might have a lot of alarms in the applications. We might only want to send out the most important alarms. So we can add filters here, so only filter on specific names or specific groups or specific texts. In this case we will only have a few alarms, so there's no real need to add anything here. We can also change how the status should be when we send this alarm distribution. The most natural would be that we have an active alarm. In some cases also might want to send out inactive alarms or acknowledged alarms. And the last thing we need to configure for the routing table is that we will need to configure what time is actually the day shift and night shift. So for the day shift you would add a period, for example weekly, and the day, the time, and that's then given a unique name. So for example, every Tuesday between 6 o'clock in the morning and maybe 7 o'clock at night, we would like it to be the day shift, and the night shift should be between 7 o'clock at night every week to maybe, let's say, 4 o'clock in the morning. And you can add a lot of different times here, so you can really go in deep here and configure this exactly how you would like it to work. So that's the routing configuration. Then you need to actually configure the different devices that should receive this. So email devices, you need to configure the SMMP server, the email server that you're using, the name that should be shown as the sender name, the email address. So let's say call it IX panel 12123 and give it an email address. Then you would add the SMTP server name or IP address. I don't have an active server running where I can do this, but if I had, I would just enter the IP address here. Then I have some distribution configuration here. And in the bottom here, this is the most important here, is that you can configure how the email should look. So the subject should contain the state and time. And here we have all the different information that you can choose from. And how the body should be configured. So you can just add some free text here if you want to. Or add some other information. This allows you to configure how this information should be presented to the people who are receiving it. And then for printer devices, you would do the same thing. You select how the printer is connected, USB, Ethernet, serial, what type of printer it is, if it's an inkjet or a laserjet, orientation of the page, font size, and the same here, we can configure how the text should be shown. And SMS, you would add the URL to the web SMS service and then the body again. And TCP server is used if you would connect to a separate server instead of having this be its own server. I don't have a active server to show you exactly what this would do, but to give you the general sense is now when an alarm is generated, it will be distributed to all these different receivers. We will print it, we will send an SMS, and we will send an email. So since it's today and it's Tuesday, the email will be sent to Axel and the SMS will be sent to Axel. So that's alarm distribution server. The last point on the agenda is Audit Trail. And the Audit Trail is used for logging user actions in a secure database. This is its own separate database. And you can have different sample strategies, either cyclic or FDA. And you can completely customize the logging so that it only logs exactly what you want it to log. The Audit Trail is very important in many different industries, such as food and beverage, pharmaceutical industries, where you need to have some sort of accountability on who is changing the parameters of the application. So I would like to show this to you now. So let's create a new screen and add the background screen. So the first thing we need to do is that we need to add an audit trail to the system, add the actual database. The same way as we did with Alarm Distributor, we right-click in the Project Explorer and add the audit trail. So we have a lot of options on what you should log. You can log trend history, showing trend legends, so basically every action you can think about, or every action that we have in IX, you can log that to the audit trail. You can go in here and fully customize. I want to log this, this, not this, and so on. Default is that we log everything. Then we have the logging strategy, either FDA or cyclic buffering. The main difference here is that the FDA will fill up the database, and when the database is full, it wants you to back the database up, then it will start from the beginning again. Whereas the cyclic buffering, when it reaches full, it will remove the oldest logged item and replace it with the newest. Then you have selecting the size of the actual database. 1 megabyte is the default, and that logs a lot of items in it, but you can increase this if you want to. The database is stored in the internal memory, so depending on what panel you have, you will have different amounts of memory available for you. But you can see that down here in the project size. So to show you this, the next thing we need to do is that we need to go into the tags. And way to the right here we have log to audit. So we can actually go in and change on each tag if you want this tag, value change on this tag to be logged to the database. And you can do this by just adding the checkbox here. And if you want to add a little bit more information to the logging of the data, you can go to the Audit Trail description here and add a description to the logging. So we might have a very cryptic name of the tag. We might want to have a more clear text information on what this tag actually does. So if we go up here to the top and take tag 1 for example, we go in here and add a static description. Maybe motor is too hot. So now when we log this value change event on this tag, you will actually see this text that I just entered. You can also have a dynamic description, so you can have different description depending on the actual value of the tag. So you might have, for example, taking motor example here, you can have the description motor is too hot when it is actually too hot, and motor is too cold when it's actually too cold. You can do a lot of configuration here. We will stick with the static description. So that's actually configuring all the basic stuff we need for the audit trail to work. But the audit trail works on users, so it will log which user is logged in when an action is carried out on the screen. So we actually need to go in here and create a new user so we can actually see that something is happening here. So I covered security in the basic webinar, so I'll just go through it quite fast. So we just added 2 users, Axel and administrator. We need to add two buttons here, so we can log in and log out with the different users. And we'll add an analog numeric so we can see that we can change the tag value, and that is then updated in the audit trail. So as I said, the audit trail is logged in a database. So if we don't do anything, everything will be logged to the database, but we can't look in it except if we go into the file system or we make a backup to a USB disk. To actually see the audit trail in runtime, we need to create a audit trail viewer, and we have it up here. Let's see. Like that. We add a button here so we can move between the different screens here. So we can jump back to the audit screen, and from the audit screen we add a button to jump to the audit screen so we can see what is actually logged. As I said, this is not necessary to actually log to the database. This is only so we can look at what's logged. Some other things we can do with the Audit Trail is that we have some other actions on it. If we go in here to the actions again, we can go into Audit Trail and we can export Audit Trail database. What this will do is that in runtime we will be presented with a dialog box where we can select where we would like this to be stored to, a USB stick or a CF card. As we are running in simulation mode, we can't use this. So let's run this and see what the Audit Trail does. So we're validating, and should be getting the application up here shortly. So jump to the Audit Trail screen, and made a little bit of a mistake here. I forgot to add the action on the security here, so we didn't have a login action on it, or a logout. That's a good thing about having the simulation, that you can, if you figure out that you made a mistake, you just fix it very fast, just to run the simulation again. So we are starting up here. So let's log in. Let's change the value here, then maybe log out, log in as a different user, so we're logging in as administrator. Change the value again, then might try logging in with the wrong password, so let's try Axel and then enter a wrong password. So let's jump to the audit here. We can see what we have done here. So we can see that in the beginning we had no user logged in, and we had a couple of block jumps. So we showed the screen, audit screen, with pressing this exact button at this time. We had a login action, and after that Axel was the logged in user. We had a logout action, another login action, value change. We can see the value before and after we changed the tag value. Then we had a login action again and a show screen action. So you can see we track everything in quite good detail. We track what button was used for an action and what the action actually was. By going back with the Audit Trail, you can see exactly what happened, what led up to a standstill of the machine or a crash in the system or anything like that. You can track that row by row, time by time, so you can see exactly what's happening. So that was Audit Trail, and we're now finished with the presentation. just some short mentioning here. After we're finished with the webinar, we still have the questioning part left, but if you need to reach us, me as the presenter, you can reach me on the email address below here. Technical support, sales, you can either send an email or just call them. On the web, we have ix.qsicorp.com, where you can get information about IX and everything around that, and also get a free software download of IX Developer that runs for 30 days. Or you can go to BeijerElectronics.com for other information regarding IX. So now it's time for questions. So I will give the word to Todd. Have you got any questions, Todd?
I don't yet. If you have any questions, please go ahead and type them in now into the GoToWebinar box. Like I said, Axel is here for the next couple minutes to answer those. Also, a copy of this PowerPoint presentation, the sample application that Axel built today, and a recording of this presentation will be available on ix.qsicorp.com. Don't see any questions as of yet. Maybe you've done such a good job, Axel, that there are no other questions out there.
Sorry, my microphone was muted there for a short second. What I said was, if you get any questions later after you download the software and play around a little bit, you can just send me an email and I will be glad to help you, or you can get in contact with technical support. Anyway, we are glad to help you with any questions you have.
Okay, Axel, don't see any questions coming in, so I think we'll go ahead and end the webinar now, and appreciate Axel for your time, and also appreciate all those who attended today. And once again, this will be available on the website along with the introduction to IX that's also up there by the end of the day.